This is Precalculus, Onramps, and this is a post-Unit 3 test, but review for the midterm. So I'm going to answer each one of these questions to help students better understand this. Sometimes they work these in groups, and so when they actually comes down to doing it on their own, they don't really remember how to do it. So I'm going to show how to do this. It says, evaluate the following using properties of exponents and logarithms. And let me rewrite this. 1/4 log base 11 of 16. Oh, 11 raised to that power. So if I can get a number raised to the log of the same base as the number, they just cancel each other out. They're inverse functions. So I want to get this 1/4 out of here. So I can have 11 to the log 11, and then whatever the argument is, the argument what you're taking the log of will be the number. So I'm going to raise 16 to the 1/4. It's 11 raised to the log base 11 of 16 to the 1/4. Those go away, so this is 16 to the 1/4. In other words, that's at the fourth root of 16. Well, 16 is 2. 2 times 2 is 4. 8, 16. 2 to the 4th power raised to the 1/4 power. I can rewrite 16 as 2 to the 4th. And when I have a power raised to a power, I multiply them. 4 times 1/4 is 1. 2 to the 1st power equals 2. Bam. Then I have this next one, log to the base 3 of 1/81. Well, again, if I can get the log base and the argument to be the same number, it'll just be 1, and then I can take any exponent, put it in the front, and that'll be the answer. So I can rewrite 81 as 3 to some power. 3 times 3 is 9, times 3 is 27, times 3 is 81. Since it's in the denominator, I'm going to write log base 3 of 3 to the -4th power. Then I can take that power and put it in front. That equals -4 times log base 3 of 3. That's just 1, so the answer is -4. Or you can remember at that step, that's just, it goes away there, inverse, and it's going to be -4. But anyway, that's how I got the answer, -4 for that one. Next. Question 2. A house is purchased for $300,000 and its value appreciates. Let me see. I'm going to write it here so that if I need to write anything down. House is purchased for $300,000 and its value appreciates. That means it rises. And the question is this growth or decay? Well, if the value rises, it's growth. The value of a car starts at $25,000 and depreciates. Depreciates means goes down. Is this growth or decay? It's decay because the value is going down. That's that question number 2. Here's number 3. Let's see. Number 3, I'm going to paste it like that. Here's a half-life formula. N of t equals N0. That's the starting amount times e to the -t. T is the time it takes in whatever the units of the half-life is. For example, if the half-life is in days, then t is in days. If the half-life is in hours, t is in hours. Natural log of 2 divided by h, which is the half-life. N of 0 is the initial amount. T is time. H is the half-life. The half-life of caffeine in a healthy adult is 5.7 hours. Jeremiah drinks 16 ounces of caffeinated coffee. How long will it take for only 40% of the caffeine? Well, it doesn't say how much caffeine is in 16 ounces of caffeinated coffee, but it doesn't matter because the new amount divided by the initial amount is going to be the amount remaining, and it says 40%. So this is 0.4 equals, and then I've got e to the -t, natural log of 2 divided by h. Now I'm going to write this as a fraction, the 0.4, because a lot of times, and I know on this one, the multiple choice relies on fraction. 0.4, I can write that as 40 over 100, or 4 over 10, and that's 2/5, equals e to the -t, natural log of 2 divided by h. Well, what is h? H is 5.7. 5.7. Okay, and now I'll just take the natural log of both sides. Remember, the natural log of e, they just cancel out. So log of 2/5 equals negative t, natural log of 2 divided by 5.7. Do I have that right? 5.7, yes. So now I'll multiply 5.7 by both sides and divide both sides by negative log of 2. I get log of 2/5 times 5.7 divided by negative natural log of 2. Now, that's t. That's going to get the right answer, and I can calculate it and then check it against the answer choices. But here are the answer choices, and notice the correct answer isn't what I wrote. It's log of 5/2 and then divided by log of 2. Well, if I flip this fraction, it's really raised to the -1 power. So 2/5 is 5/2 to the -1 power, and then I can put the -1 out in front. Exponent can go out in front, and the negatives cancel, and that's 5.7 natural log of 5/2 divided by natural log of 2. And they do this and then put the 5/7 over here, or 5.7 over here. Let me get more room so I can write it neater. They put times 5.7 over here, but either way, that's the answer. Log of 5/2 divided by log of 2, natural log, of course, times 5.7, not 5/7. All right, there's that one. Question 4, solve for x. Well, let's see. And the answers are in here. This student got, well, we're going to see the student actually got a higher score than was calculated because there's a problem, and we'll get to that problem later. So remember, with log equations, I want to try to get log to the same base on both sides, and this 4 isn't log to the base 2, so can I rewrite that? And then whenever I have separate logs added, I can multiply the arguments in one log, and if they're divided, I can subtract. But how do I get 4? Well, log 2 of something, I'll call it y, equals 4. Then I can do the old fish hook. 2 to the 4th equals y. 2 times 2 is 8, 2 is 16. 2 times 2 is 4, times 2 is 8, times 2 is 16, y is 16. So this is log base 2 of x plus log base 2 of x minus 6 equals, I need this room, sir, so I'm going to move this. So move it over. Well, I need more room than that, so I'll have to. I need room. This is why I like doing things on a computer, because I can manipulate. Oh, whoops. I can manipulate if I do it right. Okay. What's going on? I can manipulate, so okay, I kept hitting the mouse button at the wrong time. So this is log base 2 of 16, because I said log base 2 of y equals 4. I found out y is 16, so log base 2 of 16 is 4. Well, now I can combine these two. If I zoom out a little bit, you can see the whole thing. I will combine these two, and this is log base 2 of x times x minus 6 equals log base 2 of 16. And what's x times x minus 6 is x squared minus 6x equals 16. And I do that because if the log to some base of an argument equals log same base of a different argument, then those arguments must be equal. The other way I can do it is I can do 2 raised to both, and then the 2 in the log base 2 are inverse functions, and they just go away, or it equals 1, and I take this exponent and I put it out in front, whatever. So x squared minus 6x equals 16, x squared minus 6x minus 16 equals 0. I need numbers that multiply to 16, add to negative 6, negative 8, and positive 2. So this is x minus 8 times x plus 2 equals 0. So x is 8 or negative 2. Now whenever I solve log equations like this, I've got to plug these answers back into the equation to make sure I don't have any extraneous solutions. In other words, if I'm taking the log of a number less than 0, a negative number, that doesn't exist, it's undefined. So I've got to be very careful. So if I put negative 2, log base 2 of negative 2 is undefined, so negative 2 is out. And then 8 is positive, 8 minus 6 is 2, those all work. So 8 is the only answer. If you put 8, -2, you're going to get it wrong because -2 is an extraneous solution. All right, there's that one. Here's another one. Determine the equation of the exponential function in the form h of x equals a times b to the x that passes through the following points, -1 1/3 and 4 32/3. Well, two ways I can do this, and I'm going to show you on Desmos. You can also do it on your TI-84. I don't think when this is given on a test, the intention is that you're going to do this on a calculator, but I'll show it on Desmos anyway, and then I'll do it by hand, so show both ways. If I go to Desmos, Desmore or less, I call it Desmos, and I can make a table. On your TI-84, you'd go stat and then add the x values in L1 and the y values in L2. I get -1, 1/3, and 4 32/3. And it says it's an exponential function, so I'll press this button. You would go to stat, and then you arrow over 1, and I think calculate it, and then go down to exponential regression. And notice the r squared is is 1, which means it's 100% accurate. It's 0.6667, which is 2/3 times 2 to the x. So this is 2, h of x equals 0.66667, 2/3 times 2 to the x. So a, what does it ask for? Determine the equation. So a, this is a, and b is 2. A is 2/3, b is 2. How would I calculate that without a calculator? Well, I can just plug these values into the equation and then solve that system. So I get, this is h of x, and then this is x. So 1/3 equals a times b to the -1, and then I also have 32/3 equals a times b to the 4th. If b to the -1, I can rewrite that as 1 over b, and then I can multiply both sides by b. b over 3 equals a. So now I can plug that in for a here. 32/3 times b over 3 times b to the 4th. I just plugged in b over 3 for a. b times b to the 4th is b to the 5th, so 32/3 equals b to the 5th over 3. And since they're both over the same denominator, 32 equals b to the 5th. What number multiplied by itself 5 times is 32? Or 32 is 2 to the 5th power. 2 times 2 is 4, times 2 is 8, 2 is 16, 2 is 32. So 2 to the 5th equals b to the 5th. b is equal to 2. And now I know that a equals b over 3 equals 2 over 3. So again, I find the equation is h of x equals 2/3 times 2 to the x power. A is 2/3, b is 2. All right, that's that one. What's the next? What's next? Given a logarithmic function, let's see. Let me do this. I will paste it like that. Give myself more room. All right, here's my logarithmic function. Log base 2 of x plus 2 minus 4. Well, log is, this plus 2 is just gonna, the basic log function looks like this. It just increases in a decreasing rate, and it gets closer and closer to 0 without ever crossing it. You have to know these parent functions. If I do plus 2, I move it 1, 2 to the left. So instead of 0 being the asymptote, -2 is going to be the asymptote. That's that part. X, f of x, that's the question. X equals -2. You don't know that right away, but x equals -2. Whatever's in the argument, set it equal to 0. X plus 2 equals 0. X equals -2 is the asymptote. And then it moves it down 4. So it's just going to take this whole thing and shift it down 4 units. Well, that doesn't change it increasing or decreasing, so that's how it comes out to increasing function. What is the y-intercept? Set x equals 0. So log base 2 of 0 plus 2 is 2, minus 4. Well, log base 2 of 2 is 1. 1 minus 4 is -3. So the y-intercept is 0 minus 3. Y-intercept. And that's how you get this. I don't know what they put. 0, 0 minus 3. This is the y-intercept, 0 minus 3. And then I've already done the asymptotes. So there's that question. Here's the one where this student put in an answer, and it was marked wrong, but the student's answer is actually correct. So this student has to take it upon himself to go tell it to the teacher. He's got to go tell the teacher, I want my extra point. Every point counts. Go get your extra point, kid. The latest rare disease, XP, has entered your math classroom of 30. The students affected by the disease is modeled by the logistic function, P of t equals 150 divided by 5 plus 25e to the minus 0.45t, where P of t represents the number of students that understand exponential equations, I guess, and t is time in days. How many students understand initially? Well, P of t, check this out. If I take 155 and 25 and divide them all by 5, I get 30 divided by 1 plus 5, e to the negative 0.45t. And remember, t is time, so initially time is 0. Negative 0.45 times 0 is 0. E to the 0 is 1. 5 times 1 is 5. So this is 30. Initially, it's 30 over 1 plus 5 is 6, which is 5. So 5 students. That should be 5. And the student did get that right. See, 5 check mark. Then it says, what is a carrying capacity? Well, the carrying capacity, once I've simplified, is the number on top. That's the value of k, the carrying capacity. The maximum number of students who can understand exponents, who get this disease, XP. Now, the student put in 30, which is actually correct. For some reason, this thing went at 150. But 150 is not the carrying capacity. How could it be? There's only 30 students. More than 30 students cannot understand exponential or exponential equations, whatever, can't get this disease in a classroom of 30. So no, you have to simplify it, and then 30 is the answer. So the answer to part B is 30. This student had it marked wrong. Go tell the teacher, because this should be marked right, and you should get credit for that answer. 150 is wrong, 30 is right. Then we've got, I think it's only one more. How do you like that? Only one more. And again, this was a group quiz, so I just want to make sure the student got some of these right without necessarily understanding, because the group was working it together. And sometimes in a group you have one very smart person or a number of smart people. And when I say smart, people who pick things up very quickly and at the time of the quiz understand it, whereas someone else may take a little more time. And so they're a little shaky when the group quiz. I shouldn't say smart. Maybe some people who are quicker to pick it up, some people are slower, or some people who are smart and just were a little bit lazy and didn't do their studies up until the group quiz, because they said, well, the group will carry me. Well, the group carried you on the group quiz, but it's not going to carry you when you're on the test, because that's one-on-one. So make sure, even if you don't understand it on group quiz time, make sure to then look at the answers that you know are correct and figure out how to get those. So remember, to expand a log, and that's what this thing is about, expanding this, anything that's multiply, I separate the logs and add them. Anything is divided is subtraction. So this is log of x to the cube power. Well, I guess normally it's written like this, x cubed plus log of x plus 1 squared, see, because that's multiplied, minus log of x minus 2 to the fifth. And then with logs, anything that's an exponent, I can put it in the front. So this is 3 log x plus 2 log x plus 1 minus 5 log x minus 2. And let me see. X is a, b is 2. This sign should be minus. C is 5. And d is x minus 2. And so that would be the answer for that question. So this is just I can't remember what it was called again. This was a review based on Unit 3, but they're going over it in order to get ready for a midterm test. And I just answered all the questions on there, which again, this student had right, but for some reason, one of his right answers was marked wrong. So again, I remind you, on question 7, make sure you get credit for that 30. 30 is correct. 150 is incorrect. Go get your credit so you have 100 instead of a 94. Every point counts. That's it for this video.